number 1 together, this one will not be a multiple choice test or a multiple choice question on the test. And there's several things that you have to answer. And I may even add more to it, okay? So this question will be just like what you're going to see on your test, not multiple choice. It says, sketch the graph of each function. What is the parent function? Describe the translation. Is the function a growth, decay, or neither? Why? And what is the equation of the asymptote? So you have to answer all those things, okay? So we're going to do number 1. Sometimes I like to kind of write out the answers before I do the graph, whatever you want to do. But let's figure out what the parent function is first. Alright, the parent function is y equals, remember when you're talking about an exponential, it's just y equals and your base raised up to the power of x. That fraction will need to be in parentheses. So describe the translation. The only difference in the what we're graphing and the parent function is our a is 1/2, right? So if our a is a number between 0 and 1, what does that tell us? Is it a stretch or a compression? That's right, kids, it's a compression. This is between 0 and 1. So this is a compression. I'm going to say because a is between, and its absolute value of a is between 0 and 1. Is it an exponential growth or an exponential decay? It's going to be a decay, and you know that because your base, your value of b, is also between 0 and 1. So it said, is the function growth, decay, or neither, and why? So I'm going to say decay because b is between 0 and 1. What's our asymptote going to be on this one? Remember, this is an exponential function. So exponential functions have horizontal asymptotes, right? Does this have a k? No, so that means k is what? 0. So what's the equation of our asymptote? Y equals 0. Horizontal lines are always going to be y equals, and vertical lines will always be x equals. So your h and your k are both at 0. So it doesn't go up, down, it doesn't go left or right. And it did not ask me to describe the domain and the range, but I'm going to do that. I'll do that after I graph. Okay, so I know it's going to be a decay. Do I know what my y-intercept is going to be? I do. Remember, if h and k are both 0, which they are, your y-intercept is going to be whatever a is. So it's going to be at 1/2. And we can also plug that into, we can make a little table of values and find that as well if we forget that rule. Okay? But if you have a number for h or k, then a is not going to be your y-intercept. So make sure you remember that. Alright, so I have a general idea of what it's going to look like, but let me go ahead and find a few ordered pairs, and I'll just plug them into my equation and figure out exactly what my graph is going to look like. I'm going to start with the regulars. Remember, for exponential functions, it's easier for us to pick values for x and plug them in than it is for us to figure values for y and plug it in. And these are fractions, so we might get decimals, but that's no big deal because you can use a calculator on this part, okay? So I'm just going to pick the regular old -2, -1, 0, which we already know the answer to, 1, and 2. So I'm going to take my equation, I'm going to show my work. Now you could do 1/6 raised to the negative 2 in your calculator, but let me just show you, remember what this means. 1/6 is being raised to the negative 2. So since the fraction is in parentheses, we know 1 is being raised to the negative 2 and 6 is being raised to the negative 2. Well, what do we do with that? Well, we know what to do when we have a negative exponent, okay? The 1, if I want to make its exponent positive, I'll move it to the denominator. The 6 has a negative exponent, so if I want to make it positive, I'll move it to the numerator. So what's 6 squared divided by 1 squared? 36. So basically that's 1/2 times 36, which means half of 36 is what? 18. So when x is negative 2, y is 18. So let me plug in negative 1. 1/2 times 1 raised to the negative 1 over 6 raised to the negative 1. Which we know the 6 is going to move to the numerator. The 1's going to move to the denominator. They both have an exponent of 1, so what's that going to simplify to? Just 6, right? So what's half of 6? 3. We already know when x is 0 what y is going to be, because that's our y-intercept, but we'll do the math anyway. 1/2 times 1/6 raised to the 0. What is 1/6 raised to the 0 power? 1. And 1/2 times 1 is 1/2. Plug in a 1. Alright, so we'll take care of the exponent first. 1/6 raised to the first power is 1/6. Remember to multiply fractions, numerator times numerator, denominator times denominator. So numerator times numerator is 1, denominator times denominator is 12. And then my last one, 1/2 times 1/6 quantity squared. So that is 1/2 times. That exponent goes to the numerator and the denominator because of the parentheses, so that's important. So that's going to be 1 squared over 6 squared. So 1 squared is 1, 6 squared is 36. Numerator times numerator is 1, and denominator times denominator was 2 times 36. 72. That's a very small number. Remember, if you miss any part of this, I'm going to record it and put it on Edmodo so you can go back and watch it at your own leisure. Alright, I will graph these ordered pairs. You got to make sure you graph correctly. You know what a graph is supposed to look like. So if your turns out weird, like it starts going great and then you just start getting weird bumps in it, you know you probably did your math wrong somewhere. So go back and check your ordered pairs because you know what the graph should look like. Alright, when x is negative 2, y is 18. When x is negative 1, y is 3. Oops, graphed that wrong. Hopefully, oh, I graphed both of them. Wait. No, I didn't. Already did that one. Negative 1, 3, 0, 1/2. I didn't make a mistake. When x is 1, y is 1/12. When x is 2. So we obviously could graph more points than that. but we don't need to. We know it's getting close to the asymptote, right? So I don't want to go across that line. My graph does not look pretty. That's okay. We knew our asymptote was right here at y equals 0. What's my domain going to be? All possible x values for this graph. Is there any value for x that I could not plug into the equation and simplify? No. So what's the domain? Bless you. All real numbers. What's my range going to be? All possible y values. It's going to be what? Y has to be greater than 0, or all real numbers greater than 0. If our asymptote is at y equals 0, you can't have any y values at -2, -5, bless you, -20. You can't even have a y value at 0. So all real numbers greater than 0, or y is greater than 0. So for my end behavior, and I forgot to type that in as one of the questions, but you're going to have to be able to tell me what the end behavior is. You have to do it for both sides. So the side of the graph that's not approaching the asymptote is the easiest side. So I like to start there first, right? So on this side of the graph, what is your, when your arrow's going in this direction, what are your x values approaching? Your x values, negative infinity. Your x values are approaching negative infinity, right? When your arrow's going that way. So as x approaches negative infinity, what is y approaching? Bless you. Up here, up here. Positive infinity. On this side, the arrow, when your graph is going in this direction to the right, what is x approaching? Positive infinity. As y is approaching what? Very good. So that took a lot of work on that one problem. That'll be worth several points on the test, because all of those, you answered so many questions about that one graph. All right? And you'll get partial credit if you get one little thing wrong. I'm not counting the whole thing wrong. Each individual question will be worth its own points. Everybody cool with that? Yeah. Number 2, you have to do on your own. And 3, you have to do on your own. Number 2 is similar to number 1 because your h is 0 and k is 0. So you're not going to shift left, right, up or down, vertical or horizontal. Number 3, you do have an h and a k and an a. So you're going to have some more shifts there. Okay? Alright, let's look down at the next section. Solve each equation. Do not use a calculator. The reason you can't use calculators on these is because you can write both sides with the same base. Okay? If you couldn't, then you would be able to use a calculator. So on the first one, our variable is in the exponent, right? Our bases are already the same. So we'll forget about the bases, set the exponent equal to each other, and solve for the variable. And this one's kind of tricky. You got to think about it. So I'm going to set 3x equal to negative 2x. I've got x's on the left side of the equation and x's on the right side of the equation. What should I do? I'm trying to solve for x. I need to get them both on the same side, right? So I'm going to, you could subtract 3x from both sides, or you could add 2x to both sides. It doesn't matter. I'm choosing to add 2x to both sides of the equation. 3x plus 2x is 5x. What's negative 2x plus 2x. 0. A lot of students get to this point and they're like, well, that can't, I mean, that's not even possible, so it's undefined. Is that true? No. I have to divide both sides by 5. And what is 0 divided by 5? 0. What if it was 5 divided by 0? What would it be? Undefined. Error. Yeah, you can't do that. There's no such thing. You can't divide by 0. But if 0's in the numerator, that's okay. That reduces to 0. If 0's in the denominator, that's not okay. You have to, it's just undefined. Or no real number. Alright, look at the number 5. 81 and 243. Do you think we could write both sides with a base of 81? Well, 81 to the first power is 81. Let's see what 81 squared is. 6,561. So that's not going to work. So do you think a 9, you say? 9? Well, we know 9 squared is 81, so that'll work. Let's see, what is 9 cubed? 729. So 9's not going to work. 3, okay. I'm going to go ahead and write these because you might be onto something with that. 3 to the first is 3. 3 squared is 9. 3 cubed is 27. 3 to the fourth is 81, so that works for the 81. And 3 raised to the fifth power is 243. So a base of 3 will work. Remember, I'm not showing you how to use the calculator on test day. That's part of the test. So if you're using my calculator or your calculator, make sure you know how to use your own calculator. Alright, so I'm going to write both sides with the same base. This one is a little different than problems we've had before, but you know how to do it. We just haven't had one just exactly like it, but you need to know how to do this one. Alright, so for 81, we're going to do 3 to the fourth power. 81 already has an exponent. Don't forget about it. For 243, I'm going to replace that with 3 to the fifth power. But 243 already had an exponent of 2x minus 1. It's 2 terms. No big deal. We know how to distribute, right? So when you have a power to a power, we know that you keep the base and do what to the exponents? Multiply them. So 4 times 3x is 12x equals. Over here, we're just going to have to distribute. No big deal. Keep the base of 3. Distribute. What's 5 times 2x? 10x. 5 times negative 1? Negative 5. And I'm running out of room, so I'm going to go over to the side. Once my bases are equal, then my exponents must be equal. So I'm going to set my exponents equal to each other. And solve for the variable. So in this case, I'm going to get my x's together, so I'm choosing to subtract 10x from both sides. 12x minus 10x is 2x. These cancel and leaves me with negative 5. Divide by 2 and x equals negative 5 halves. On the answer key on this one left it as negative 5 halves. And so if this were multiple choice, that's probably how they would leave it on this particular, the software that I used to create this review. Anybody have questions on that? Okay, 9 and 10. Solve each equation, round your answer to the nearest thousand. The variable is in the exponent. So, can we, 9 raised to what power is 98? We're going to have to, 9 squared is 81. 9 cubed is a large number. So that's going to be some decimal, right? So this is written as an exponential equation. I'm going to rewrite it as a logarithmic equation and see if that helps. So that would be log base what? Of equals n. So if we use a change of base formula, we can figure out what n is equal to. But you have to make sure you put the change of base formula in your calculator correctly, right? So remember, change of base, you do log of 98 divided by log of 9. If you do that backwards, you'll get an answer, but it won't be the right one. So if you're using a TI-30XA, you have to put, it's kind of backwards, like we talked about a million times, 98 log divided by 9 log. And don't forget, you have to push equal after that. So this would round to the nearest 10 thousandths. So that's tenths, hundredths, thousandths, 10 thousandths. You look to the number to the right, so we stay the same. So 2.0867. Remember, I will not remind you how to do that on test day. Everybody good? All right, next page. Same problem or same directions. Remember, you cannot write your question as a logarithm until it's in exponential form, which means you just have a base raised to an exponent set equal to something. So 11 is already in exponential form. 12 is already in exponential form. Your base is e, right? So when you write that, you're going to get a natural logarithm. Is 13 ready to write as a logarithm? No. Is 14 ready to write as a logarithm? Alright. I'm going to do 13 with you because it's tricky. It even tricked me. I was like, why is my answer not working out? I just wasn't thinking. I started to get this in logarithmic form, or I'm sorry, exponential form, by adding 5. Why is that not okay? Because it's multiplication, right? That's negative 5 times 7 raised to the m power. So I was like, oh, what was I thinking? I just saw the negative 5 and automatically added 5. But I can't do that because it's being multiplied. So I had to divide both sides by negative 5. And when I did that, I got 7 raised to the m equals, we know a negative divided by a negative is a positive. And 72 divided by 5, I'm going to get a decimal, and that's okay. 14.4, positive 14.4. Now it's an exponential form. Now I can write it as a logarithm. So that's log base 7 of 14.4 equals m. Put that into my calculator using change of base. So 14.4 log divided by 7 log. Don't forget to hit equals. And I'm rounding that to the nearest 10 thousandths place. So tenths, hundredths, thousandths, 10 thousandths. I'll look to the right that says go up. So 1.3707 approximately. I can always check this, right? It's easiest to do once it's in exponential form. Just take what I got for m, plug it in, and I'm rounding, so it's not going to be exact. 7 raised to the 1.3707, and I get 14.4 approximately. That's what I should get, so I'm good to go. Coolio? Alright, 15, or I'm sorry, yeah, on your page 15. 15 and 16 says identify the domain and range of each, then sketch the graph. What is the parent function? Describe the translation. What is the equation of the asymptote? On 15 and 16, those are logarithms. So they look similar to exponential, but remember, the big difference is that your asymptote is vertical, not horizontal. On number 15, can you look at that and tell what your asymptote is going to be? If this were an exponential function, our asymptote would be at k, right? Because that's your horizontal translation. But this is a logarithmic function, so your asymptote is at h, and you got to change the sign, remember? So it's because it moves, or it shifts, the asymptote shifts vertically, so it's left and right. So our asymptote is going to be at -5. So I'm going to go ahead and draw that in. At x equals -5. My parent function is y equals log base 6 of x. Remember, you don't put an a in a parent function, you don't put an h, you don't put a k. You just put y equals log, the base, and what you're taking the log up. So if I am supposed to describe the translation, what's the -3? That's my k. What's it going to make the graph do? Shift down 3. And the h is +5. What's that going to make my graph do? Left 5. Everything's shifting down 3 and shifting left 5. Alright, well, let me find some ordered pairs. Now, I'm not real sure what I want to start with. I know I can't have any x values that are -5 or less than -5. So I would probably maybe try -4, maybe 0, maybe 2, 4. Some x values to the right of the asymptote. Start there. So I'm going to plug in, let me plug in -4. I'm probably going to need some extra paper to show you this. So I'll do that right here. So y equals log base 6 of x plus 5 minus 3. So I'm plugging in an x of -4. So that's y equals log base 6, -4 plus 5 is 1. And then I have -3. Now be careful when you're doing this. You cannot do 1 minus 3. Alright? This log base 6 of 1 all goes together. The -3, I'm not subtracting 3 from 1. I'm subtracting 3 from log base 6 of 1. Okay? So what do you think we could do to continue simplifying this? Change a base formula, right? On log base 6 of 1. Let's put that in the calculator and see what that is. So 1 log divided by 6 log equals 0, but I don't think that's right. Did I do that correctly? Let me go back. -4 plus 5 is 1. Oh, yeah, duh. I'm sorry. 0, and then I have the -3. I haven't done that part yet. So 0 minus 3 is -3. When x is -4, y is -3. I'm going to go ahead and plot that. Bless you. I'm going to plot, I'm going to see when x is 0. So y equals log base 6 of 0 plus 5 and then minus 3. So that's log base 6 of 5 minus 3. Again, I can't do 5 minus 3. I'm subtracting 3 from log base 6 of 5. If I make a mistake, y'all tell me. So I'm going to do change of base on this. 5 log divided by 6 log equals approximately, I'm going to go with 0.8982. And then I can subtract 3. So let's go with negative 2.1. I'm just estimating anyway. So go back over here. When x is 0, y is negative 2.1. Now I'm just randomly picking these numbers because I know about what my graph should look like, okay? And I see what the size of the graph that they gave me. So I'm going to pick 6. I'll just plug in a 6. I know it's going to come down like this and then go in this direction. If I wasn't sure, keep picking more ordered pairs. But I know I can't, an x of negative 5 is not going to work. Negative 6, negative 7, negative 8, those aren't going to work. So I'm just randomly going to pick a 6. So where I see x, I'll plug in a 6. Y equals log base 6 of 11 minus 3. I'm going to use change of base on that. 11 log divided by 6 log equals, it's always a good idea to double check your math, 1.3383 minus 3. And I get negative 1.67 approximately. So I know this kind of looks like a straight line the way it's going, right? But I know what the graph of a logarithm looks like. So I know it's not a straight line. If you're not sure, pick more values for x, plug them in. Let's see, I don't think I answered all of the questions. Identify the domain and range. We haven't done that yet. Okay, so remember, domain and range are kind of different than they are on exponential because an logarithm and an exponential function are the inverse of each other. So for domain, that's all of your possible x values. What is your domain going to be for this? X is greater than negative 5. Very good. Because I can't have any x values that are negative 5 or less than negative 5. What's your range going to be? Are there any y values that you could not choose? No. So range is all real numbers. Remember, we could write it as negative infinity to positive infinity interval notation. You could see it either way. We already said what our asymptote was. We described the translation. It did not ask you to do in behavior, but I want to include that because you will have to do that on your test. So let me describe the side that doesn't have, it's not approaching the asymptote first. When your graph is going in the direction of this arrow, what is x approaching? Positive infinity. And what is y approaching? My y's, it kind of looks like there's an asymptote up there, but there's no horizontal asymptote for an exponential function. This is just going to keep getting taller and taller and taller. Your y's are going to keep rising. Positive infinity. We have to describe both sides. There's 2 arrows on every graph, so you have to describe both of them. So the end behavior over here, what is x approaching? Negative 5. Very nice. And what is y approaching? What are your y's doing? Negative infinity. That squeezed a lot of stuff on there. So again, that's going to be worth a lot of points.
How many of these questions are we going to have?
On the graphs, I'll probably put one exponential function graph and one logarithmic function graph and ask you all the questions about each one of them, because these are time consuming and I don't need a million of them to know if you know how to do it or not. Okay, 18 or 17 through 20, super easy. You just have to make sure you get everything in the right spot. The directions just say, write each equation in exponential form. That's it. You're not solving for anything. You're not doing anything except for taking it from logarithmic form to exponential form. Okay? So in this case, exponential form, remember your little swirly, right? Your base raised to whatever's on the other side of the equation gives you what you're taking the log of. See if that's a true statement. 2 raised to the 6th power is 64. That's what a logarithm means. 2 raised to what exponent gives you what's in x's spot. So that's 4 super simple questions right there. Right on? You can do the rest of those yourself. Backside, 21 through 24 says rewrite each equation in logarithmic form. You're not solving for anything. You're just changing the form. It's currently in exponential form. We're going to put it in logarithmic form. So that'd be log base what? Of equals. That's it. Oh, you can't see it. Log base A of 44 equals B. 25 through 28. Use a calculator to approximate each to the nearest thousandth. We're just using change of base. That's all. So for 25, that would be 38 log divided by 2 log. Don't forget to put equal, because I guarantee this will probably be one of the choices if it's multiple choice. So put equal. You're rounding to the nearest thousandths, tenths, hundredths, thousandths. So that's going to be 5.248. $29, suppose you deposit $2,000 in a savings account. These won't be multiple choice, by the way. Suppose you deposit $2,000 in a savings account that pays interest at an annual rate of 5%. No money is added or withdrawn from the account. This problem, they're compounding interest at a particular time period, not continuously. We learned 2 different formulas. You have to know which one to use when. So for these problems, you're going to use the A of t equals A, lowercase a, 1 plus r raised to the t. Don't forget your rate has to be as in decimal form. On the first 2, they tell you the time. On the second 2, they tell you the amount in the account, but you got to find the time. So time is going to be in the exponent. You're going to need to know how to do logarithms to solve that one. Okay. Number 30, suppose you deposit $6,000 in a savings account that pays interest at an annual rate of 4%, compounded continuously. We can't use the same formula that we just used on the last one, because when you see continuously, that tells you have to change over to the very last formula that we learned on page 27, and that formula is A of t equals P, remember that stands for principal, times E, that's your natural logarithm, right, your base, raised to the rate times time. On the test, I'll put these formulas on the board, but I'm not going to tell you when to use which one and what each thing stands for. You got to know how to do that. Alright, so I did several of these for you. You have to do the rest on your own. I will have them completely worked out in on Edmodo, hopefully before I leave here today, so that will give you time to check it. If you just go, well, she's got it on Edmodo, I'm just going to pull it up and copy hers. Well, that's going to get you points on this assignment. That's not really going to help you on the test to know if you get it or not, right? So that is not the purpose of me working it out and putting it on Edmodo. The purpose is for you to check yourself before you wreck yourself, right? All right, that's the end.